Dear incoming math students, this is Alejandro Aceves. I'm the chair of the Department of Mathematics at SMU, and throughout this short presentation I will give you some highlights about our degree programs in mathematics. We have a group of faculty engaged in different areas of research in applied mathematics. Throughout your studies at SMU, you will see many of them in your classes, from differential equations to linear algebra to more advanced courses. Should be interested and engaged in research, you will become part of the research team once you narrow your preferences in terms of the areas of application. Why do we care about math? And in our department, being a very applied mathematics department, mathematics is at the core of, and it's a language of modeling different phenomena. The one that I'm presented here represent areas of research our faculty is engaged in. That includes the modeling of the power grid, modeling of neuroscience, climate modeling, and the areas of physics such as nonlinear optics and photonics. Our undergraduate degree programs are twofold. We have a Bachelor of Science and a Bachelor of Arts. The Bachelor of Science degree is the purpose of it is for those of you who want to do a career in industry, or more so that you want to pursue an education in graduate programs in applied mathematics or engineering. It could be also an attractive second major for students whose primary interest is in computer science, economics, electrical engineering, and similar disciplines. The Bachelor of Arts degree instead is designed for students who need a traditional mathematics understanding and degree for careers in teaching, industry, business, and government. It can also be viewed as an attractive second major for disciplines in the social science, business, humanities, or fine arts. Students pursuing a math major, I also encourage them to consider doing concurrently a major in Bachelor of Science in Data Science. The combination of a math degree and a data science degree will lead you to very good jobs in finance, the medical field, and other areas in business and industry. The specializations of our Bachelor of Science degree are classified into pure or applied/numerical. You can also choose instead an engineering specialization, or a third alternative is a computer science specialization. Once you are close to taking advanced courses, and with the advice of some of our faculty, depending on your interest, you will choose the most suitable specialization based on your particular interest. In the modern way, we go through our undergraduate education in the most of the schools that carry Bachelor of Science and other degrees, is that you should have experiences beyond the classroom. I highlight here two activities, one through monthly meetings as a math club for undergraduates, and with many activities including preparing students interested in taking the most prestigious and oldest math competition known as the Putnam Mathematical Competition. In the most recent one of our students, Mr. Lee, ranked in the top 94 percentile. That means between number 1 and 192, right along students from Princeton, MIT, Harvard, and other prestigious institutions. Another set of activities that our undergrads are engaged in once they begin to do some research is participating in regional and national conferences. The picture here shows our students together with students from institutions from Texas and Louisiana that recently attended a regional conference of our professional society, the Society for Industrial and Applied Mathematics. Also beyond the classroom, and more so towards summer activities, mainly for sophomores and juniors, they are typically in two forms. One is what it's called a research experience for undergraduates, REUs. These are programs supported by the National Science Foundation. They run across many universities in the country. For example, the example shown here is one at Dartmouth College, which will run virtually this summer in areas of inverse problems, computational methods applied to the environment. I highlight this one because one of our SMU students is participating in this REU. Another form of experience beyond the classroom in the summer is through internships. More common are internships in national labs. The example I highlight here is one of the Los Alamos National Lab on data science. And again, I highlight this one in particular because one of our SMU math majors is currently participating in virtual form in the data science scale school. The format in both of them consists of working in groups with other undergrads from all across the nation with the mentors, engage in research projects, giving presentations at the end of your experience. Both cases, these are students participating in these activities are well supported through stipends, with stipends throughout the experience, 6 to 7 weeks. We were pleased to see that our math majors are doing well in the market. One way to, or a metric about this, how well our students do after graduation is salaries 1 year after graduation. And there is this report based on data from the US Department of Education stating that the math majors at SMU do well, and we rank number 14. If you can see in this table, number 1 is MIT, number 2 Johns Hopkins, then we have Cornell, and as you go down the list, these are really well-known universities. We are there at number 14, where the median salary after graduation is close to $60,000. Part of why our SMU students do so well in terms of salary is the applied math flavor of our majors combined with the fact that most of them do double majors. Also, starting in 2019, our department received an award from the National Science Foundation to run a program called Research Training Groups. As the name says, this is a combination of research and training that goes from PhD students to undergraduate students, and it also includes young postdoctoral fellows. In our case, we have 3 core areas of research. One is on computation-enabled investigations into circuits and cognition. This is neuroscience with collaborations with UT Southwestern. The second topic is nonlinear dynamics and the modeling of large systems such as the power grid. And the third one is modeling complex transport processes in nanoscale manufacturing with close collaboration with the SMU School of Engineering. The type of activities briefly include, in terms of structure, is a vertically integrated groups that includes faculty, postdocs, PhD students, and undergraduates like you. Along the type of activities we run year-round, and that as you engage in research, we build partnerships. The examples here are UT Southwestern, the School of Engineering, and Department of Energy laboratories. Throughout that, we can also forward our students to competitive internships. We will also be running in the next few years our own research experience for our undergraduate programs. These will be 10-week summer programs, and our SMU math majors would be invited and eligible to participate. An example of one of these vertical activity that is currently ongoing is a group of one faculty mentor, that is myself, a first-year graduate student, Sabrina, and a math major, Jonathan. We're working on the behavior of the COVID-19 as it relates to Dallas County. There is a model based on differential equations, and we are tracking the data and forecasting different scenarios based on behavior that we put in our model. So once again, on behalf of my colleagues, the whole Department of Mathematics, the faculty of the Department of Mathematics, we welcome you. We look forward to seeing you in our classes in the next 4 years. And we wish you well, stay healthy, and hope to see you soon.